This is a video for Math 105, section 1.6, and I'm going to solve problem 44 from the problems in the back of the section in the e-text. Okay, so it says solve using an appropriate substitution. 4x to the fourth equals 3x squared minus 9. Okay, first thing I like to do is set it up, so it's in general form equals 0. So in other words, I want all of the stuff on one side equals 0. So I'm going to move the 13x squared and the minus 9 to the other side. So this would be 4x to the fourth. Here it's plus, so this would be minus 13x squared. Here it's minus, so here it'd be plus 9. All equals 0. Okay, so now it looks kind of like, ax squared plus bx plus c, but it's not squared and just x is fourth and squared. So what you can do is turn it into a quadratic form by the substitution u equals x squared. Then notice that u squared is x squared squared, which is x to the fourth. Okay, so that means over here, if I change to u's, I've got 4u squared minus 13u plus 9 equals 0. This is in u, but it's quadratic, so I can solve it using any of my ways to solve a quadratic equation. So let's use the quadratic formula. Okay, so when I have u, let's just note that for the quadratic formula, u is going to equal, it's a giant fraction, minus b plus or minus, then the square root. Under the square root is b squared minus 4ac, and the denominator of the fraction is 2a. Okay, so now if I do that here, u is going to equal, let's see, b is negative 13, so minus b is just plus 13. b is negative 13, so I've got negative 13 squared minus 4, a is 4, and c is 9. And then on the bottom, we've got 2 times a, 2 times 4. Now, sometimes, if you want to make this clearer for yourself, write out what a, b, and c are off to the side. Sometimes that will help you. It helps me. All right, so I'm just plugging into the quadratic formula. I'm just plugging in these 3 numbers for a, b, and c. Now simplify. Well, okay. I just simplified the denominator. 2 times 4 is 8. 13 plus or minus the square root. So I figure out what's under the square root. Negative 13 squared. Well, 13 times 13 is 169. And now I've got minus 4 times 4 times 9. 4 times 4 is 16. 16 times 9 is 16 times 9. 9 times 10 is 90. 9 times 6 is 54, so it's 144. So this is minus 144. Okay, well, now I finish what's under the square root. Negative 13 plus or minus under the square root. 169 minus 144 is 25. And I go, aha, I know that's a nice number. It's 13 plus or minus 5 over 8. Okay, now notice this splits, right? I get u is 13 plus 5 over 8, or u is 13 minus 5 over 8. 13 plus 5 over 8 is 18 over 8, which reduces to 9 over 4. 13 minus 5 over 8 is 8 over 8, which is just 1. Sorry, u. So I have the answers for u, but note u equals x squared right here. So I need to find out what x's are. So here I've got u equals 9 over 4, u equals 1. So if I take u equals 9 over 4, that means x squared equals 9 over 4. And so that means x is plus or minus the square root of 9 over 4. So x is plus or minus 3/2. Or u equals 1, which means x squared equals 1, which means x equals plus or minus the square root of 1, which means x equals plus or minus 1. Okay, so my solution are plus or minus 1, plus or minus 3/2, or if you want to change that to a mixed number, it would be like that. So notice there's 4 solutions for x. And that makes sense because this is a degree 4 equation. Okay, so this is an example of substitution, often called a u substitution. U equals x squared, and how we change a problem that's degree 4 into degree 2 quadratic. The advantage of that is we've got the quadratic formula. We can solve any quadratic. However, once we solve it, we only have the answers for u. We have to then go back and sort of change back from u's to x's using the relationship we set at the beginning. Okay, thank you.